Hello everyone. Welcome to our group project video about the Reynolds number.
Okay, hello everyone. My name is Sirian Henry. My ID is TH20036. Today we are going to do an experiment which is to determine Reynolds number. So in this experiment, there are 4 roles which are planar that filled by me, Rayon, experimenter by Adam, analyst by Amirul, and report writer by Izwani. So any idea by experimenter?
Hello everyone, my name is Muhammad Adam. So as an experimenter, I suggest that we use a pipe and then we can control the velocity of the water flow, and then from there we will fill a empty jar and we record the time taken to jar being filled, and then from there we can find the value of Reynolds number. At the first part, we use the slow water flow, and then we go to the high velocity, and then from there we can find the that's all.
So hello everyone, we meet again. So my name is Ryan Henry and my ID is TH20036 and my role is as a planner.
Assalamualaikum and hi everyone. My name is Amir Rahman bin Zulkifli. My method number is TH20023. So for the experiment, my role is analyst.
Hello everyone, my name is Muhammad Adam, TH20025, and my role in this experiment is an experimenter.
Hey everyone, my name is Izwani Najiba and ID number is TH20030. I am as a report writer for this experiment.
So we are from group 2 and we will present about our project. We present about our project which is Reynolds numbers. To begin, let's talk about introduction. So in this experiment, we will talk about fluid flow. There are 3 types of fluid flow, which are laminar, transitional, and turbulent. The transitional from laminar to turbulent flow depends on geometry, surface roughness, flow velocity, surface temperature, and type of fluid. As we know, in circular pipe is laminar when the Reynolds number is less than 2000. For Reynolds number that are 4000 and above are turbulent, and Reynolds numbers that are between 2000 and 4000 are transitional. Thank you.
So for our objective for this experiment is to determine the Reynolds number for a pipe flow in different flow regime which is laminar and turbulent, and then to prove the measureless Reynolds number using the Reynolds number formula. So on the right side is the Reynolds number formula. So RE is stand for Reynolds number, equal to density of the fluid times velocity of the fluid times length per dynamic viscosity of the fluid, equal to velocity of the fluid times length equal to kinematic viscosity of the fluid. So we will use the formula to calculate the Reynolds number.
Okay, first thing first, we have to have this jar. So this jar is, as we can see on the bottom of the jar, there's a website of this where it made and the name of the item, which is PBT 500BC. And from the website, I found out that this jar contain of 500 milliliter. And next, we have to have a water pipe. to make the turbulent and laminar flow, and then a stopwatch. We have to find out this diameter, so we can open this and we can measure the diameter of the inside diameter of this pipe. So now we find out the inside diameter of this pipe is 2 centimeter. Okay. Next, we have to set this water flow in a laminar and also in a turbulent flow. We have to open this valve slowly. Okay, as we can see here. Okay, the water flow in a very smooth condition and on a straight streamline. You can see this. Okay. So this is a laminar flow. This is because of the molecule of the water inside this stream is highly ordered. Okay. Then we have to increase the velocity of the water stream. As we can see, the water is not in straight line anymore. Okay, you can see the water stream become more choppy, and this is a turbulent flow because of the fluctuation of the velocity, and the molecule of this stream is highly disordered. That is the turbulent flow. So when the water is flowing in laminar flow, so we have to calculate, we have to record how much time it takes to fill this jar when we put the jar inside this water stream. So we have to start the stopwatch simultaneously. 1, 2, 3. So when we have to stop the, okay, so then have to repeat this. So first we have to record this data and then we repeat it, reset, then we repeat it 3 times. Full of jar. Okay. Then have to repeat this. So first we have to record this data and then we repeat it, reset, then we repeat it 3 times. So now the water flow is in a turbulent flow, so we have to do the same thing and record the time taken. 1, 2, 3. So we have to repeat this experiment for 3 times.
As a conclusion, the value of the Reynolds number obtained from the first flow condition is equal to 281.51, where the value is less than 2000. So the flow is laminar because the momentum transfer between the molecules is less and the velocity profile becomes parabolic. In the second flow condition, the Reynolds number we get is 5943.64, where the value is more than 4000. We can say that the flow tends to be turbulent due to high velocity and low viscosity. Finally, based on the results of the experiment, the characteristics of the liquid are successfully determined. Thus, the objective of the experiment are achieved. Thank you.